Hello, this is Renaud from Agilian, and I'm going to talk about the preparations before production and why it's very important to keep it very structured. Okay, even when you see some seemingly simple assembly work like this, a lot of work is necessary first before going into production, at least before going into high quantity production. And really, there's two options to simplify. You can go with suppliers that follow little structure and they can promise you, oh yeah, we can go very fast into making thousands and tens of thousands of units. And you want to change this, you want to change that, is okay, let's adjust. We're very agile, okay. However, that doesn't work well with production. I will explain why. In these cases, you have a small probability that everything goes right and a very high probability things go wrong, as I mentioned here. And the more complex, the more unique the product, the smaller the chance that everything goes right. If they did that with automotive cars, 100% chance it goes very, very wrong. Okay, so that's why the best manufacturers, they go, it's a very step-by-step process, very structured. It feels slow, and there's a proven framework, and it's better not to go out of it. But the result is much more predictable. And once you are on the right track, then you can say, okay, we'll go into higher quantity here. We can scale up and we can make sure that we'll get at least that level of quality. Okay. Without all this structure, it's very difficult to promise anything. Okay. That's really the key message here. And let me explain why. Production is like a puzzle, actually. You need every piece of the puzzle, right quality, right quantity, right time. Okay. Not to mention the right price, of course, but at least to get things going. What are these pieces of the puzzle? Well, the product design, yeah, including packaging, including firmware, including everything. The components need to be good quality, and I will talk more about that right after. All the little tooling, fixtures, etc., test stations, etc., and the bigger tooling, maybe plastic injection molds, die casting molds, etc. Yeah, the machining operations, surface treatment operations, etc., and the equipment need to be within control, well maintained, etc., to reach the desired result. Test station, test methods, yes, alignment between customer, contract manufacturer, and suppliers of components, alignment of test methods, etc., criteria, and of course the human element, the operators, inspectors, etc. Not just in final assembly, testing, packaging, but also in upstream operations. And the key is that if anything is late or flawed or missing, it disrupts production. Okay, you have one thing missing here, it's terrible. Okay, there's a lot of forces that tend to derail production or try to derail production. And that's what manufacturers have to fight every day. The requirements from customers, well, they might be unclear, they might be unspecific or completely missing. And then they will get some product and they will say, oh, no, I cannot accept that. It's a big problem. Then you go into rework, scrap, etc. Misaligned quality standard or measurement systems. I mentioned before, variation when you make components. Any kind of fabrication, machining, or manual assembly, you have variations in dimensions, yeah, color, reliability, and so on. Okay, so there's always a variation, and we need to make sure that the underlying process is stable enough. Okay, operators on the lines, they might not work very consistently. That's the human element. They might make mistakes, especially when they're tired. It's just not just production, also quality staff, logistics staff, and so on. If there is automated equipment, especially if it's custom built, there might be a lot of issues. It might not be up. It might create some quality issues and so on. And the customers might try to push some last-minute changes in the design, in the orders, etc. Okay, very difficult to get good production going with all these forces, and these are just a few of them. Okay, I mentioned I would come back to the topic of components. let's pick, let's say, average electronic product that is innovative, that was developed, new to the world. Let's say it might have a custom display, might have a custom battery pack, certainly has a custom PCBA. Okay, the enclosure is probably custom, might even have some special surface treatment, right? So it might be, I don't know, a die cast with some kind of powder coating, maybe anodizing, a bit difficult, etc. Might be plastic, might be something else with some nice PVD coating or electroplating and so on, right? So lots of ways to go wrong here, both in the enclosure itself and the surface treatment. Some mechanical parts might be custom packaging, especially nice consumer products might have a nice custom packaging. And then there's all the other off-the-shelf components. And all of them can derail production, right? If one of them is wrong, one of them has an issue, production cannot happen in good conditions, okay? And obviously the risk is much higher with the critical components like custom PCBA, maybe custom battery pack, and so on, than off-the-shelf components. But yeah, any one of them can derail everything. So I just mentioned critical components. As I mentioned, one of them arrives defective or arrives late, everything stops, right? And these are some examples, as I mentioned earlier. And there's various kinds of risks. It's not just that they might be defective. They might also, one of them might arrive late. Well, nothing can be built and shipped, right? Some of them might have suddenly very long lead times. Some of them might be fake, refurbished, or go end of life. So all of this needs to be managed, right? And I want to emphasize an important concept, the closer to production. So here's mass production. Here's the very beginning of the product design and development. Okay. And then at one point, it goes from engineering work of problem solving and trying different things to, hey, now the product design is frozen and we need to go through this NPI process, what we call tooling validation, pre-production, mass production. A lot of people call DVT, PVT, MP. And it really needs to be very structured. It's a very different approach from the earlier engineering-led phases, okay? And especially if I go back to the graph here, there's a big difference between EVT and DVT. Okay, so before engineering validation, yeah, changes are relatively easy. It's expected to have trial and error and so on. However, after that, flexibility drops a lot. The changes might lead to very, very costly redesigns. Okay, and a lot of people have this analogy that a factory is like a 3D printer. Okay, I read that first, I think, in a book called Product Realization. Yeah, and it's like a 3D printer. Just press the button, and then it's a very straightforward process. Actually, the right analogy, I think, is more like a commercial real estate project. And if at some point you make some changes, well, it's a disaster, right? You really don't want to do that. And everything needs to be planned very, very carefully. Here I have a few examples, but I'm going to go very fast. Maybe a last-minute engineering change leads to some production stops. A lot of operators, okay, have to wait, and a lot of engineers have to work on it. Okay, all of this is costly. Another one, very typical, especially toward the beginning of a new production, is that incoming quality is not acceptable. Maybe one of the components here has a certain percentage of defectives, but it's in a rush, then it's sorted on the line, and actually they find it's not 10%, maybe it's 14% that are no good. Okay, and this leads to all kinds of issues, and all of this is extra cost. And of course, this is just for one part and a relatively low defect rate, right? And sometimes it's much higher. Some customers like to say, well, no, pre-production, mass production, let's order the components once and we get all the components made in one batch. Okay, first it defeats the purpose of a pre-production pilot run, of doing several pilot runs also for the custom design components, but also the problem is that pre-production pilot runs sometimes surface some issues and then leads to some kind of design change in the BOM, and then some of the components, sometimes very expensive components, are no longer needed. And if they're custom designed, custom made, well, they have to be scrapped, and that can be very, very expensive. This is not something I pull out of my hat. This is really from real experience. Okay, new product introduction is all about go-no-go gates. And really, when we are here going into pre-production, and here from pre-production going into mass production, these two gates are quite important. I just want to go a little bit more into these ones. So the first one is getting into pre-production from phase four, our phase 4 putting validation to phase 5 pre-production. Okay. So there are requirements, typical requirements. Okay, product design obviously has to be verified. Prototypes, etc., tooling samples. Okay, against the product requirement document, but also it's been validated. Compliance testing, reliability testing, or also for manufacturability, for testability, and so on. Packaging and labeling, ready to go. Production tooling, really validated. That's really the previous phase. What it was all about. Acceptance criteria, yes, with the proof samples, maybe limit samples, how to measure, and so on and so forth. A clear plan for assembly, testing, packaging. Yeah, it needs to be pretty clear in the minds of production people. The parties involved need to agree that there's no major blocking issues or very high risk. And also, ideally, there's something a lot of people forget. When it's a very unique, a very new product, you don't really know how people will use it. And if you make some extra tooling samples and you have maybe 10, 20 of them in the hands of real users for a while, then you get feedback from them. It really reduces the risk quite a bit. So this was typical requirements for getting into pre-production. Now let's look at those for going into mass production. So obviously the pre-production pilot runs must have taken place, and from A to Z. So it's not just about assembly, testing, packing. It's also about the custom design parts. They must have been made in small batches, if possible, more than one batch, to see the typical kind of variation we can expect. All of these data, quality, such as first pass yield, for example, and efficiency. Okay, is there anything really blocking? Are the materials flowing? All the stations are okay. Critical suppliers, yes, their readiness, the process stability, that's what I mentioned a bit here. Jigs, fixtures, automated equipment, other types of tooling validated. All of this comes from the pre-production pilot runs. And then there's some issues, and top issues have been not just analyzed, but the biggest issues have been addressed. Countermeasures have been put in place. And it's not like, oh, okay, we'll fix that, and then we'll see in the first mass production run, and then we can go from 50 pieces to 10,000 pieces. No. If your countermeasures have not been verified in another pre-production pilot run, there's a risk. There's a residual risk here. And that's why we always suggest, especially for relatively complex products, to go through several pre-production pilot runs. And in some cases, 3, 4, 5, it's safer, right? Now, quantity might increase a little bit every time, and we don't have to keep a long gap between them. But just doing one, usually means high risk. And let me just show this and I'll be done, is that if you're lucky, this is, let's say, the variation of the measurements on a critical to quality measurement point, let's say. Or it could be a lot of different things. And the idea is that you do batch 1, batch 2, batch 3, etc. The process is stable, and what you see in the first one is what you see repeatedly after that. And everything is green, so it's within tolerance. But sometimes you do the first time and you say, well, I have a good feeling, everything is all right. Then you go with pre-production pilot number 2, and everything is completely out of tolerance, again and again. And then this is a very unstable process, right? But if you just do one pre-production pilot run, you don't know about that. And variation is a fact of life. We cannot eliminate variation, but we have to manage it. And if the process is really that unstable, and it creates a lot of issues for the quality of the final product, or the ability of the manufacturing process to make the required quantities, then some changes have to be made before ramping up into high quantity. Okay, that's it. I hope that was clear. Let us know if you have any issues. Thanks.